Hello guys, welcome to CSES group. The channel is dedicated for preparation of electrical engineering optional paper for UPSC CSE. Now, why this is required? First of all, let us go with some statistics. So UPSC annual report, I have referred for this. So there are basically 26 optional paper as per the notification 2020, and paper number 6 and 7 of UPSC, that is the optional subject, paper 1 and paper 2. You can choose electrical engineering as one of the optional out of this 26. Now, why to choose engineering as optional? Okay, that's the biggest question. And then basically why to choose electrical engineering as the optional? So let's go to the data which is provided by 69th annual report of UPSC, uploaded on 4th of March 2020. What it says, first of all, geography is the most preferred subject among the optional subjects chosen by the candidates, followed by sociology, political science, and international relations. Now the question arises, if the geography is most preferred subject, why to go for the engineering subject? Now if you look into the statistics, the academic background of the recommended candidates are engineering 66.2%, humanities 21.8%, science background 6.4%, and medical background 5.6%. So look at here guys, 66.2% candidates are from engineering background, but the most preferred subject is geography. That means something is really missing, and one of the important point is that we don't have proper sources for engineering preparation. Now if you see the success rate of geography and electrical engineering, again this is data provided by UPSC. So success rate in geography is 5.5%, whereas for the electrical engineering it is 9.8%. That means it is almost 1.8 times the success rate of geography. So it's always preferable if you are from electrical engineering background or electronics background or in instrumentation, you can go for the electrical engineering optional paper. Okay, let's come to the syllabus part of electrical engineering optional. Paper 1 consists of circuit theory, signal system, EM theory, analog electronics, digital electronics, energy conversion, power electronics, analog communication, whereas paper 2 consists of control system, microprocessor, microcomputers, measurement and instrumentation, power system protection, and digital communication. Okay, so if you see the common subjects between electronics and electrical engineering, you will find circuit theory, everyone will study for electrical and electronics. Signal system again is a common subject for these two branches. EM theory is also common for these two branches. Analog also, digital also. Energy conversion, it's purely for electrical. Power electronics we have studied in our time, but I think now it is not there. Maybe sometimes they will choose as elective. Okay, analog communication, obviously electronic subject. Okay, so electrical also they will study, and electronics people also will study the analog communication. Now if you go to the paper 2, all are mostly the electrical subjects, but everyone will study from electronics also, like the control system. Microprocessor and microcomputers are not too tough, you can very well manage with that. Measurements and instrumentation, again we have studied in our time, but now they have removed from the electronics syllabus. And then power system, it's electrical portion, again power system protection, again electrical, and digital communication. So if you see, there are so many common subjects for electronics and electrical engineering, hence you can very well prepare even if you are from either of the background. Okay, now the circuit theory syllabus consists of circuits and components, network graphs, KVL, KCL, KVL, circuit analysis method using nodal, mesh, basic network theorems and applications, transient analysis, RL, RC, and RLC circuits, sinusoidal steady state analysis, resonant circuits, coupled circuits, balanced three-phase circuits, and two-port networks. So if you see the syllabus, it's very general. Most of the university, I can say 99.9% of the universities of India are following such kind of syllabus, or is covering all the topics from the circuit theory. Okay, except for sometimes the three-phase circuit in some of the universities. The books which are preferred for this, for UPSC CSE, the first one is Circuit Theory by A. Chakravarti, because most of the questions you can find directly coming from the A. Chakravarti book. Sadyuki is also one of the good book for this. Shom series, you will get so many unsolved or solved problems for that. Let's go to the question paper of 2011. So let us start with 2011 question. This is the question number 1A, and let us see the question. The question is a storage battery has no load terminal voltage of 6 volt. Okay. When the current through the battery is 100 amperes, the terminal voltage drops to 5 volts. Okay. Show the pictorial representation of the battery as a constant current source. So let us see what is the data given. What are the data given in your question? You have no load voltage is 6 volt. Fine, that is here. The terminal drop can be 5 volt. That is also there. Now the terminal drop is 5 volt only when you have some internal resistance present in the circuit. Hence we can draw the circuit like this. You have a 6 volt battery here, and then internal resistance here, and then one load resistance here. Now uh, the question is pictorial representation of the battery as a constant current source. So now we have the model of the present question, and it can be shown as a constant current source. That means you have to apply the Norton's theorem. So basically you have the Thevenin's model, and then you are moving to the Norton solution of this. So you need to find out the RL, and you need to find out the R internal. So current through the load is 100 amperes, that is fine, that is given in the equation itself, and the voltage across the load terminal is 5 volt. Hence the load terminal can be the load resistance can be written as 5 divided by 100, that is 0.05 ohms. So once you have this, similarly you can apply the loop and you can comment on what is the internal resistance of the circuit. So you just apply the loop equation, that is the KVL. So 6 volt is equals to 100 into R internal plus 5 volts. So that comes as R internal is 0.01 ohms. Now your equivalent circuits looks like this. I have written all the actual values which we got from this calculation. R internal is 0.01 ohms. The load resistance is 0.05 ohms, and the battery is 6 volts. So this is what the Thevenin equivalent. Now you have to go for the Norton's equivalent of the circuit. So apply Norton's theorem. For that, what you need to do is you have to remove this load resistance and then apply a short circuit to it. So this is what the Norton equivalent model of the given question. I have applied a short circuit here, and I am calculating ISC, the short circuit current of the circuit. Now if you apply the simple loop equation to it, you will find ISC is equals to 6 divided by 0.01, that is 600 amperes. That means the current source is a constant 600 amperes current source, and its resistance is 0.01. So that is what the answer of the given question. You need to draw in this way because it is asking for the pictorial representation of the battery as a constant current source. Now we'll go for the next question. Look at the question first. It is find the current I which is flowing in the 10 ohm. Right? So that is what 1.24 amperes. So that's done. And please don't forget to highlight the answers when you are writing for the such kind of examination. That is very important. So do some ink, different coloring pen with you, and have some coloring pen with you, and just highlight that one with a box like this. Okay. Next question is question number 12b. The question is state and prove maximum power transfer theorem. Again, I have taken this from A. Chakravarti's book. So the statement of the theorem is a resistance load connected to a DC network receives maximum power when the load resistance is equal to the internal resistance. Now what is internal resistance? That is the Thevenin's equivalent resistance of the circuit of source network as seen from the load terminal. Okay, this is what the standard statement which is given in the A. Chakravarti's book. So we need to prove the theorem also. Hence I have taken very simple circuit in which I have the internal resistance or the Thevenin equivalent resistance as RTH. Voltage I am taking as V0, and the load resistance which is varying here is taken as RL. So if you write that is the load current equation, you will find it is V0 divided by RTH plus RL. That is what the power delivered. No, sorry, the power delivered to the load is given by PL, which is equals to I square RL. I value you have already calculated. Let us substitute that and you will get the power value. Now you need to find out what will be the value of load resistance RL such that the power will be maximum. Now in order to do that, you need to differentiate this PL with respect to the RL and equate that to 0. Whatever RL you will find there, that you need to again substitute in the PL. So that's what we are doing here. D by dRL of PL is written as this equation. Okay, that's a very standard method. Please go through these equations. Okay, and you will find that you will end up with such kind of things. The rest of the constant will vanish because you are having the other side 0. V0 square will also vanish because it's a common, and finally you will end up with RTH is equals to RL. Okay, so this is what the proof of your maximum power transfer theorem, and the maximum power delivered by the load is equals to V square divided by RTH. Again, don't forget to write this because that is also part of the proof. Okay, so this is what your question number 12b. Let's move to the next question, that is 2c. Now what is 2c? The switch is closed at t is equals to 0. Using Laplace transform, determine I1t and I2t. Okay, so where is I1t? It is already mentioned in the question. This is I1t and this is I2t. Now please understand before moving for this solution, when switch is closed at t equal to 0, that means the inductor is initially unenergized. Now please remember guys, when the inductor is initially unenergized, that means it is basically one open circuit. Okay, like this, or maybe you can have such kind of representation. Okay, so open circuit means initially you will not get any current I2 value. The only current which will be flowing in the circuit immediately after closing the switch is I1. Okay, so you can very well say that at t is equals to 0 plus I2 is 0, and at t is equals to 0 plus I1 is equals to 12 divided by 2 plus 2, which is equals to 12 divided by 4, hence 3. So please don't forget your initial value of I1 is 3 and initial value of I2 is 0. Now let's move to the solution part. You need to first write the KVL, that is the loop equation for this I1. So I am writing here, loop equation is 12, then 2 times I1t plus 2 into, again this resistance is shared by these two loops, hence I1t minus I2t. If you further solve it, you will find 12 is equals to 4 times of I1t minus 2 times of I2t. Okay, taking the Laplace transform of the equation, you will find that this 12 can be replaced by 12 by s. This will be replaced by 4 times of I1s. The other will be replaced by, or the transform is minus 2 into I2s. Okay, now let's write the loop equation for the other loop. It is 2 times I2 into t, sorry, I2 of t minus I1t plus 2 times the I2t plus 1 by t d by dt of I2t, right? So this is because of this inductor. Please don't forget it is given by L di by dt. So L value is 1 by 2, hence you are writing 1 by 2 d by dt of I2t. Okay, so equate that to 0, and if you do that, taking the Laplace transform, you will find that I1s is equals to I2 by 2 into S2 plus 4. Okay, this is what you will find. I have already explained in these two equations. Please go through it. And then substituting from equation number 1. Now from here, substituting the value of I1 in the equation number 1, you will find that 12 by S is equals to 2 times of I2S, which is coming from here. Okay, here you are having 1 by 2, which will get cancelled out with this 4. And hence you will end up with 2 times of I2S. This equation will, this term will come as it is, which is here, minus 2I2S, which is here. Okay, so this I have written here. Now if you further simplify it, you will find I2S is given by 12 divided by S into S plus 6. Now you cannot directly take the inverse Laplace here. You need to go for the partial fraction. Hence partial fraction is A divided by S plus B divided by S plus 6. Okay, Now you need to calculate A value and B value. I have explained that in this step. If S is equals to -6, you will get value of B. If you substitute S is equals to 0, you will get value of A, which is equals to 2. Now let us write again that I2, it is 2 divided by S plus -2 divided by S plus 6. Now taking the inverse Laplace of that, you will find it is 2 times the ut minus 2 times the e power minus 60. So let us call that equation number 3. Now moving to the other part, that is calculating I1t. Okay. So I1t, again you need to equation 2, you use the equation 2 and 1. Please go back to the previous slide and find out what is equation 1 and what is equation 2. I have already mentioned here. If you solve that in this way, you will find that the I1 is written as 3 times S plus 8 divided by S into S plus 4. Okay, so again partial fraction you need to go, and you will find A by S plus B upon S plus 4. Again, standard method for partial fraction, S is equals to 0, you will find A value is 6, S is -4, B value is -3. Okay, so substitute that and you will get I1 value in terms of Laplace as 6 divided by S minus 3 divided by S plus 4. Now taking inverse Laplace of this equation, you will find 6ut minus 3 times of e power minus 4t. Now please remember guys, I have told you that initial condition is 0. That means at t is equals to 0 plus the I1 value will be 3, and if you substitute here t is equals to 0, this term will go to 1 or will vanish to 1 because e power minus 0, basically e power 0, which is equals to 1. So 6 minus 3 is 3. So initial value of current I1 is 3, and look at here, t is 0, so e power 0 will turn to 1. Okay, please remember e power 0 is 1, and this will turn to 2 minus 2, that is I2 is 0, right? So that's why, that's how you can even verify your answer also. So this is what the answer for the given question. Now let's move to the next question. Next is question number 3b. So what is this? Let us read this. This is a little tricky question, but you will find such kind of questions they used to ask in JEE. Okay, so figure 3b, that means this one, show that two identical capacitors, that is the parallel plate capacitors, connected to a battery with switch S closed. Okay, so initially this switch S is closed. The switch S is opened and the free space between the plates of the capacitor is filled with a dielectric coefficient of value k equal to 2. Now this is very important. Find the ratio of total electrostatic energy stored in both the capacitors after introduction of the dielectric. Okay, so let us go step by step. We will read this question again through this figure. Let us try to understand what they are saying. You have two capacitors C1 and C2 which are connected in parallel here, and there is a battery source V1. Okay, and there is a switch. So switch is initially closed. That means both the capacitors are having same voltage V. Now after some time they have opened the switch and they change the dielectric coefficient value to 2, okay, of both the capacitors, and then you need to find out the electrostatic energy stored in both the capacitors for both the cases, when switch is closed and switch is open. Okay, so when switch is closed, both the capacitor will have same potential, that is V, and energy is given by 1 upon 2 CV square. Okay, so if we write for capacitor C1, it is C1 into V square, and for C2 the energy is given by 1 upon 2 C2 V square. Okay, both the capacitors are same, hence you can write C1 is equals to C2 is equals to C, okay, which I have written here, and the total energy stored in this is given by E1 plus E2. Half CV square plus half CV square will lead to CV square. Okay, so let us call that equation number 1. Now switch S is open and the dielectric constant of the capacitors are changed to K is equals to 2. So C2 is not connected to the battery, therefore the voltage across C2 will change. Please understand, C2 is not connected to the battery, so voltage will change here obviously, but C1 is still connected with the battery, so voltage will not change here. This is very important part. And then for C1 we can write the parallel equation is epsilon A by D, and the capacitance is twice of C because the dielectric coefficient value is now changed to 2. Okay, so capacitance value for C1 will change to 2C. Similarly for the C2, capacitance value will change to 2C. Okay, because you have doubled the dielectric constant. Now what about the energy stored in capacitor 1 and 2? For capacitor 1 it will not change, it will be same. That means half CV square, where C is twice of C. Okay, whereas for the capacitor 2 you need to first find out the voltage associated with that. So voltage is given by Q by C. Okay, where C is C2 because we are finding for the capacitor number 2, and that is given by Q upon 2C. And if you write in terms of V, you will find it is half V. Okay, so the voltage associated with the capacitor C2 is 1 by 2 V, and for that of capacitor 1 it is V only because the voltage across capacitor 1 will not change. Now the energy associated with the capacitor 1 is given by 1 by 2 twice of C into V square, which is equals to CV square. For capacitor 2, the energy associated is E2, which is equals to 1 upon 2 twice of C because the capacitance has changed, and voltage also has changed, which is equals to 1 upon 2 V, and then its square. Okay, so if you simplify it, you will find this is equals to 1 upon 4 CV square. Now you need to add these two terms and you will get the new electrostatic energy associated with these two, right? So E is equals to E1 plus A2, which is equals to 5 upon 4 CV square. Now you need to find out the ratio of E dash and E. So E dash by E is equals to 5 by 4. So this is what the energy ratio which is required as per the question. Thank you. This is the last question from the circuit theory for year 2011 optional electrical engineering. Please subscribe, comment and like, and share your views in the comment box. Thank you. In the next session we will be going for 2012 circuit theory questions. Thank you guys.